Hey everyone, welcome back to the channel. Take a look at the device you're watching this on. It could be a smartphone in your palm, a sleek laptop, or a powerful desktop. They're incredibly fast, connected, and woven into the fabric of our daily lives. But have you ever stopped to think about how we got here? This intricate piece of technology has a fascinating family tree, a story of innovation that spans nearly a century. Today, we're going on a journey back in time to explore the incredible evolution of computers through their different generations. We'll start in rooms filled with massive glowing machines and travel all the way to the tiny chips that power our world. It's a story of shrinking sizes and exploding power. Ready? Let's boot up our time machine. Our story begins in the 1940s and 50s, the era of the first generation of computers. Forget sleek and portable. Think big, loud, and hot. These weren't personal computers. They were colossal machines that filled entire rooms. The key technology here was the vacuum tube. Imagine thousands of these fragile, light bulb-like glass tubes working together to make calculations. Machines like the ENIAC were the titans of their time. They were groundbreaking, capable of performing calculations that would take humans weeks, but they were also incredibly high maintenance. They consumed enormous amounts of electricity, generated immense heat requiring powerful cooling systems, and the vacuum tubes would frequently burn out, making them unreliable and difficult to program. Programming was done using machine language, the most basic level of code, often by physically plugging and replugging cables. It was a painstaking process reserved for highly specialized engineers and scientists. These first-generation giants were primarily used for scientific calculations, census data, and military purposes. They were the pioneers, the clunky but crucial first step on the path to modern computing. Then came a revolutionary invention that changed everything: the transistor. In the late 1950s, the transistor ushered in the second generation of computers. It was a tiny solid-state component that replaced the bulky, fragile vacuum tube. This single change had a massive impact. Computers became significantly smaller, faster, more reliable, and much more energy. They no longer needed to occupy an entire room and didn't generate nearly as much heat. This was a huge leap forward. Programming also evolved. Instead of manual wiring, programmers could now use symbolic languages, also known as assembly languages, and later high-level programming languages like Fortran and COBOL. This made programming much more accessible and efficient. As a result, computers started to spread from niche scientific labs into the business world for tasks like payroll and inventory management. The second generation marked the moment computers began to transition from being purely scientific curiosities to becoming powerful business tools, setting the stage for even greater things to come. The evolution continued at a blistering pace. The 1960s saw the dawn of the third generation, thanks to another groundbreaking invention, the integrated circuit, or IC. You might know it as the microchip. An IC packed multiple transistors, resistors, and capacitors onto a single tiny piece of silicon. Instead of wiring individual transistors together, manufacturers could now use these compact chips. The result, computers became even smaller, faster, and cheaper to produce than their second-generation predecessors. This was the era of machines like the IBM System 360, a family of computers that offered different levels of performance but could run the same software. This was a new concept that allowed businesses to upgrade their hardware without having to rewrite all their software. Another major development was the improvement of operating systems. Users could now interact with the computer through keyboards and monitors, a much more user-friendly experience than the punch cards and printouts of earlier generations. This allowed for multitasking, where the computer could perform several jobs at once. The third generation made computers more powerful and accessible than ever, bringing us one step closer to the personal computers we know today. And that brings us to the fourth generation, which started around 1971 and continues to this day. The defining technology here is the microprocessor. What's a microprocessor? It's essentially an entire computer processor, the CPU on a single integrated circuit chip. This incredible miniaturization was the final piece of the puzzle needed to create the personal computer. Companies like Intel released powerful microprocessors that made it possible to build computers small enough and affordable enough to fit on a desk. This sparked a revolution. In the late 1970s and early 80s, we saw the birth of Apple, IBM PC, and Microsoft. For the first time, computers entered our homes, schools, and small businesses. The development of graphical user interfaces, or GUIs, with mice, windows, and icons, made computers incredibly intuitive and easy to use for the average person. No more complex command lines. The Internet also came into its own during this period, connecting these individual machines into a global network and completely transforming how we communicate, work, and access information. The power of a 1960s room-sized computer could now fit in your hand. So, what's next? We are now entering what many call the fifth generation of computing. Unlike the previous generations, this one isn't defined by a single hardware breakthrough. Instead, it's about a new way of computing centered around artificial intelligence, or AI. The goal of the fifth generation is to create devices that can understand natural language, are everyday speech, and are capable of learning and self-organization. Think about the technology you already use. Voice assistants like Siri and Alexa, recommendation engines on Netflix and Spotify, and even the complex algorithms that are starting to drive cars. These are all early examples of fifth-generation computing. This era is less about raw processing speed and more about creating intelligent systems that can reason and interact with us in more human-like ways. We're also seeing the rise of parallel processing and quantum computing. New paradigms that promise to solve problems that are currently impossible for even the most powerful supercomputers. This generation is still unfolding, but it's clear that it's poised to change our relationship with technology in ways we are just beginning to imagine. From room-sized behemoths powered by glowing vacuum tubes to the AI-driven devices in our pockets, the journey of the computer has been absolutely incredible. Each generation, the vacuum tube, the transistor, the integrated circuit, the microprocessor, and now artificial intelligence has built upon the last, making our machines exponentially smaller, faster, and smarter. This relentless pace of innovation has fundamentally reshaped our world in less than a single human lifetime. It's a powerful reminder that the technology we often take for granted today is the result of decades of brilliant minds pushing the boundaries of what's possible. What will the sixth generation look like? We can only guess, but one thing is for sure. The story of the computer is far from over. Thank you so much for joining me on this technological trip through time. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up. It really helps the channel. And if you want to see more deep dives into the world of technology, history, and science, make sure to hit that subscribe button and turn on notifications so you don't miss our next video. What tech topic should we cover next? Let me know in the comments below. Thanks again for watching, and I'll see you in the next one.